T-minus 10, 9, 8, 7, 6.
E is equal mc squared, in which energy is
steps for man.
The human genome is our shared inheritance, and it is fitting and proper to all.
Cracks and cracks.
Hi, I'm Bob McDonald. Yes, it's that time of year again when families get together, gather around their radios, and ask themselves, why don't dogs hyperventilate when they're panting? And how come restaurants can make ice cubes that are perfectly clear? And why is the hole in the ozone layer over the South Pole much bigger than the hole over the North Pole? And is it true that cats' whiskers only grow as long as their bodies are wide? Well, you've probably guessed by now that it's our annual brain-teasing, audience-pleasing, Google-seizing, mind-reasoning Quirks and Quarks holiday question show. We've selected 10 of your best science questions and hunted down 10 Canadian scientists with the answers. So sit back and put on your thinking caps while we challenge you and the experts to cite the scientific solutions. This is Quirks and Quarks.
Hi, my name is Ryan Bolter from Indian River, Prince Edward Island. My question is, can aquatic mammals like whales and dolphins only breathe out of their blowhole, or can they also breathe out of their mouths?
Joining us with the answer is Dr. John Ford from the Pacific Biological Station in Nanaimo, British Columbia. So, Dr. Ford, we know that whales came back into the water from the land, so they used to be able to breathe through their mouths. Can they still do it now?
Well, they certainly did come from a land mammal ancestry, but in moving to a fully aquatic environment, they had to have a really reliable way, essentially, of isolating the airway from the digestive tract, because there's in a fully aquatic kind of existence, there would be a real risk of aspirating or inhaling water into the lungs, and that would not be a good thing for an aquatic mammal like a whale.
Or us. We all know what that feels like when you get some water down the wrong hole.
Exactly, and as you know, we of course share the same, a common passageway until the back of the throat, where we have a little cartilaginous flap called an epiglottis that covers up our larynx, which leads down to the lungs when we swallow. But what the whales and dolphins have over the course of evolution is a system that completely isolates the two passageways, so that in fact their airway, which is known as the larynx, it goes through the food way, if you like, called the pharynx. It actually travels right through the center of it, and there is complete isolation. So when a dolphin or whale opens its mouth and swallows, there is no connection possible to the lungs. And so this way it's a fail-safe system so that they don't inhale water underwater.
Oh, so when they open their mouths to eat, if they take in water, it goes to the stomach, not the lungs.
That's right. And of course, when they surface to breathe through their blowholes, the air passes right through the center of the pharynx through this tube that basically goes directly to the lungs without any chance of connection to the stomach.
When did this separation of the breathing and the feeding apparatus occur?
Well, it's not really clear from the fossil record because it's soft tissue, and these parts aren't preserved very well in the fossil record. But it must have happened fairly early on in the evolution of whales and dolphins, because it seems to be so characteristic of across all the different family groups of cetaceans, and so it probably is key to survival as a fully aquatic mammal. Other aquatic mammals like seals and sea lions have a more conventional terrestrial mammal system, so they can actually breathe and vocalize through their mouth by opening their mouth.
So why did the whales do it, but the other sea mammals didn't do it?
Well, I think they're just different ancestry in terms of their evolutionary past, and the route that the cetaceans, the whales and dolphins, started down through evolution led to this kind of a format, which is one of a whole range of remarkable adaptations that allow these animals to live fully in an aquatic environment, so they never have to come to land. In fact, going to land is often a disaster for an animal like this, whereas the seals and sea lions, they share many common features with terrestrial mammals, and in fact, they have to get out of the water in order to do certain life processes like giving birth to pups.
I guess having a blowhole would be the equivalent of moving your nose up to the top of your head.
Well, essentially that's what has happened through evolution. So the nostrils have essentially migrated from the tip of the nose up on top of the head, and so the nostrils go right through the skull and down through the esophagus and connect to the lungs directly. And right beneath that blowhole is a very strong muscular set of nasal plugs that ensure that even under pressure, no water can penetrate into the lungs.
Oh, so can a whale or dolphin accidentally open its blowhole underwater?
They do open their blowhole underwater, but usually or always, perhaps, in the context of releasing pressurized air to vocalize. And so by passing air over these plugs, the animals can whistle and make clicking sounds for echolocation and so on. So air is transmitted through the blowhole underwater, but generally only in one direction, and that is out.
Boy. How long can whales stay down?
It really depends on the species. Some are phenomenal divers, like the beaked whales, which are sometimes quite a small whale. They generally don't get over about 10 meters or so in most species, and they can stay down easily an hour and a half and go down to thousands of meters deep. So they are phenomenal divers.
Unbelievable. Dr. Ford, thank you very much.
You're welcome, Bob.
Dr. John Ford is head of the Cetacean Research Program at the Pacific Biological Station in Nanaimo, BC, which is part of the Department of Fisheries and Oceans, Canada.
Hi, I'm Jen Perry from Toronto, and I've been wondering why human eyeballs are opaque and white, while most other mammals and even other primates have dark eyes. Thanks.
With her eye on the answer is Dr. Suzanne MacDonald from York University. So, first of all, Dr. MacDonald, is it true that we are the only primate with white eyeballs?
Yes, it is absolutely true, and isn't that amazing?
It
because
is.
When you stop to think about it, you say, oh my God, we are the only ones with white eyeballs.
Well, is it that the part that we have white, they just have dark, or do they just have really huge pupils?
No, their pupils are, that would be very strange. No, their eyes are the same, except their sclera, that's the white part, is actually a different color. So other primates in particular have kind of amber-colored sclera or brown-colored sclera. If you look at your dog or your cat, now everyone will do that because, you never think about this before. You'll see that they're just different colored than ours are, and we have white, and we're the only species that has white.
Okay, so then on to Jen's question. Why? Why would we be unique having white sclera?
Well, the actual answer is I don't know, because nobody knows, because eyeballs don't fossilize, so we have no idea how this arose in our evolutionary history. But being a typical science person, I can speculate wildly on this.
Okay.
And there is some evidence to suggest that this hypothesis is correct. And the hypothesis is that humans have evolved to use their eyes to communicate much more so than any other species. And if you look at us, you obviously can't see us on the radio, but you can certainly imagine that when you turn your eyes, you can actually use that as a communicative gesture. And so you will look where I'm looking. So for a species like us that we're cooperative hunters, for example, that's a really great way to communicate without having to move anything except your eyes and without having to make any sounds.
Oh, look over there,
Yep.
without actually having to say it.
Exactly.
Or on the other hand, if you said something I didn't like, I could roll my eyes.
I do that all day long. Yes, rolling our yes, we can communicate a lot with our eyes. So our eyes, the hypothesis is that our eyes have evolved to enhance our gaze. So if you notice, our eyes are not only they don't only have white sclera, but they actually are much more horizontal. So they're much more almond-shaped than other species. So if you look at other species' eyes, they're mostly round. Ours are much more horizontal, and that also enhances the gaze direction. So it's a gaze direction enhancement hypothesis.
Well, why would that that evolve in humans, though, and not the other primates?
Well, that's probably the best question, is we don't really know that. But we are an unusual primate in that we have a different brain. Our brain is much more complex. And the idea is that gaze direction and using our eyes to communicate went along with some of the brain development that we have that other species don't have. The idea is that I know that you have a mind, I know that you have beliefs and knowledge and feelings, and I know that I have those too, and I know that your mind is different than my mind, and I can communicate with you with my eyes and my voice and all these other kinds of things. And that ability is not shared to the same extent with other species. And so it might be that using our eyes went along with our brains developing to have this other ability. Because using your eyes is a really sneaky way to communicate. So you can be deceptive with your eyes, you can be flirtatious with your eyes, you can actually, say a million words with your eyes. And other species don't have a million words to say. So that's kind of the idea.
That was interesting, as you just went through all of those emotions. You demonstrated that with your eyes here. It's too bad we're on radio. That was very effective. And it's interesting that a lot of animals don't like you to look at them straight on.
Exactly.
That's considered
it's a threat. And certainly in most non-human primates, it is a big threat. And if you notice, there are some species of non-human primates that have white eyelids. They have white-tipped eyelids, and they use that, so they flash their eyelids, and that's a threat. But that's not the same as having white eyes. We can actually say a lot more than just threat with our eyes. We can say a lot.
The eyes have it. Dr. McDonald, thank you very much.
My pleasure.
Dr. Suzanne McDonald is an associate professor in the Departments of Psychology and Biology at York University in Toronto.
Hi, my name is Mark Ritchie, and I'm calling from Haines Junction, Yukon, one of the best places on Earth to watch the night sky. And my question is this. With all the space junk floating around the Earth, why hasn't NASA ever used the space shuttle to pick up the bigger pieces of junk and bring them back to Earth in the empty cargo bay?
And we received a similar question from an American listener who hears us on Sirius Satellite Radio.
Hi, this is Jennifer McNeil from New Kensington, Pennsylvania. I'd like to know if anyone's working on a plan to clean up space junk.
With his eye on the sky is Hugues Gilbert from the Canadian Space Agency in Saint-Hubert, Quebec. So, Monsieur Gilbert, how much space junk is up there, and where's it all coming from?
Well, we don't know exactly how much there is up there. We can track the bigger pieces. So any object that is 10 centimeter or bigger, we can track it. We know with a relative precision what is its orbit, what is its altitude. So we can track this down. And there is about 15,000 pieces that are 10 centimeters or bigger that are up there. The biggest ones are our old satellites that are no longer functioning. So we do consider those as being a part of the space junk.
15,000.
15,000. It sounds like a big number, but you have to realize that there's a lot of space up there. If you take the geosynchronous orbit, which is where we have most of the communication satellites, it is located at 36,000 kilometers above the Earth. So if you were to consider the sphere that this creates around the Earth, you're talking about roughly 3 trillion cubic kilometers. So that's a lot of space. So 15,000 pieces that are floating in that amount of space is not that big.
Well, as you say, there's a lot of space up there, but still these things are moving pretty fast. So when there is a collision, it's a serious issue.
Yeah, absolutely. If you take the space shuttle, for instance, or the International Space Station, which is pretty close to Earth, it evolves at about 350 kilometers. And when you watch it on TV, the space shuttle and the International Space Station, it gives you the false impression that things are moving rather slowly. But actually, they're flying at between 7 and 8 kilometers per second. So that's about 20 times the speed of a bullet. Okay, now if no one cleans space junk up, how long does it remain in orbit? It depends on where it is. If you're talking about the orbit where the International Space Station is, which is about 350 or 400 kilometers, things will stay up there for a few months. So within a year, they will re-enter in the atmosphere, and most of that will get disintegrated.
because it's re-entering at such a high speed that the friction of the air will destroy these objects before they reach the Earth. If you're going to higher altitude, you can have objects that will remain in orbit for several years, and if you're in the geosynchronous orbit, which is very high, so there's very little drag up there to slow down things,